we're going to take a look at equivalent ratios. Now, a ratio is something that compares two or more things measured in the same units. And while this might sound confusing, this is something you've probably seen a lot in your life. If you've been in the kitchen making anything, a lot of times you'll see things listed in ratios. There's a whole bunch of places when we're doing some odds for gambling, sometimes they're given as ratios. So an example here, 2 cups of water to 1 cup of rice. So just check the package of rice and it says for every cup of rice that you add, you need 2 cups of boiling water. So this is an example of a ratio. 2 parts water to 1 part rice. If I didn't want a full cup of rice, maybe I wanted a smaller amount. Whatever amount of rice I put in, I got to put twice as much water. So the way that ratio would be written is 2 to 1. And we use this colon portion here. That means 2. So 2 parts to 1 part. We could scale this up, and if we needed to make a huge amount of rice, we could have 1 bucket of rice to 2 buckets of water. And so we're able to play around with these. We're just looking at the value of 2 things that have the same units, thus we don't have to say the units explicitly. There's 2 types of ratios that we work with. There's a part-to-part ratio, which is when we compare different parts of the group to each other, and that's what we did here. There's 2 parts water to 1 part rice, but there's also the part to whole comparison where we look at the part compared to the entire amount. So in this case, there's 3 cups total. 2 to 3 would be the part to whole. We'll look at an example here with concrete. So concrete's often given as a part mixture because depending on what we're building, you're building you're pouring a slab for a house foundation versus maybe a little shed in the backyard. You're going to need a different amount. So we use the ratio as the mixture. So a common concrete mix is called a 7-part mix. There's 7 parts in total, 4 parts of crushed rock, 2 parts of sand, and 1 part of cement. So the part-to-part ratio here is the 4 parts of crushed rock to 2 parts of sand to 1 part cement. So 4 to 2 to 1. So those all add up to our total of 7 parts. So that's the part-to-part-to-part, rock, sand, and cement. Now when we look at the part-to-whole ratios, it's for rock, it's 4 to 7. 4 parts rock out of the total 7 parts. For the sand, it is 2 to 7. 2 parts of the sand out of the total of 7 parts. And then the cement portion is 1 to 7. 1 part of cement to the total of 7 parts. So part to part just compares the individual parts to each other. Part to whole compares how much of that 1 part to the whole entire mixture. Another key thing with ratios is this idea of equivalent ratios. And we work with equivalent ratios often. When we're comparing 2 things together, we want to maybe scale up our recipe of rice from, I need 3 cups of rice. So how do I scale that up? So that's what we're looking at, an equivalent ratio. So equivalent ratios are 2 ratios that are the same when written in lowest terms. So an example here, 4 to 10 is equivalent to 6 to 15, and we want to show that they're equivalent. So a way to do that is that we divide those or break those down into simplest terms so we can find a common factor here. So common factor of 4 and 10. So what's the common factor between 4 and 10 is the first thing we need to look for. 4 and 10 both have a common factor of 2. So let's divide that out. When we divide 4 by 2, we're left with 2. When we divide 10 by 2, we're left with 5. So this is our 4 to 10. And then let's do the same thing with the 6 to 15. Find a common factor between 6 and 15. So the common factor between 6 and 15 is 3. 3 is our common factor. So let's divide it by 3. When we do that, 6 divided by 3 is 2. And I'm running out of room here. So 6 divided by 3 is 2. 15 divided by 3 is 5. Those are the simplified lowest terms of the two ratios, 4 to 10 and 6 to 15. They're the same. Because they're the same, these are equivalent ratios. So we can compare two ratios and see if they're equivalent by simplifying them down by common factoring them, each ratio, and getting down to the lowest terms. The other thing we can do with ratios is determine and scale up those equivalent ratios. So when we're doing this determination of making an equivalent ratio, you want to determine a relationship between two values in the same position by multiplication or division, and then multiply or divide the other known term by the value from the previous step. So what that means is we look at two terms in the same position. So in this case here, I got 5 to 3, and we want to see what ratio it equals. So 3 and 6 are in the same position. So to go from 3 to 6, because I got to go from here to here, so I got to get the 5 going from here to here. So to go from 3 to 6, I could multiply 3 by 2. So if I multiply 3 by 2, I get 6. So I'm going to do the same thing here now. I'm going to do 5 times 2. 5 times 2 gives me 10. So an equivalent ratio of 5 to 3 is 10 to 6. In the next case, I have something to 8 is equal to 40 to 32. So now I got to go from 32 down to 8 and 40 down to this missing value. To go from 32 down to 8, I'm going to need to divide. And so if I do 32 divided by 4, I get 8. So 32 divided by 4 will get me 8. And thus, if I do 40 divided by 4, I get 10. So 10 to 8 is an equivalent ratio of 40 to 32. So this here is the way to do it when it's just nice and clean with two values. However, in our third example here, we got a situation of 3. So at a school, the ratio of boys to girls to teachers is 15 to 12 to 3. There are 12 teachers in the school. We want to find out the number of boys and girls. So our first position here is boys. For every 15 boys, there's 12 girls, and there's 3 teachers. But we have 12 teachers. So let's rewrite this out similar to how we have up here. So there's a ratio of 15 to 12 to 3. And that is equivalent to some unknown quantity of boys, some unknown quantity of girls, and not an unknown quantity, but an actually known quantity of teachers, which is 12. We have 12 teachers. So there's our situation. When we go about this, we do it the same as before. We need to go from 3 to 12. We're going up, so we're multiplying. What do we multiply 3 by to get 12? 4. 3 times 4 is 12. Thus, we multiply 15 and 12 by 4. So 12 goes here, times 4. 15 goes here, times 4. 15 times 4 is going to give us 60. 12 times 4 is going to give us 48. So we have 60 boys and 48 girls. And so that gives us our comparative ratio. All right, so that's the general look at ratios. You can also check out the front matter in the textbook portion that I've included in the section 1.1. That'll be linked here with the video in the on Edsby. And from there, you can try out questions number 1, 2, 4, 6, 7, 9, and 10. So those are some good questions to take a look at. Do note, question number 6 is a multiple choice question. Thus, you are picking which of those multiple choice questions are the answer.